Okay, so in this video we will study about Poiseuille's equation and will know about how to derive the Poiseuille formula. So before this, let us consider a tube in which the water is or the fluid is flowing, and there are different layers. Now let us consider the particles are starting with same rate at this end, but since the viscosity varies according to the position, the particles in the middle region will move faster. So, on some distance, there will be some difference in there. So, it is observed that this kind of curvature is obtained. So, this type of curvature is obtained just because of the viscosity, because viscosity will let the layer that is along the center of the tube to move faster, and as we go towards the wall of the tube, the viscosity will not let that flow very smoothly. So according to this, velocity depends on the pressure difference. So you can see the pressure here is something else at point A, at point B. So the movement of particles or the fluid is basically depending upon the pressure difference. As you have studied in the case of electricity, that the value of rate of charge flow that depends on the potential difference. Similarly, here the rate of flow of the fluid depends on the pressure difference. So first, velocity depends on pressure difference. Let it be P. Second, velocity also depends on the radius of this tube. So radius of tube. As we know that the current in the electricity chapter, you must have studied about the factors affecting resistance. So this viscosity is nothing but the internal property of substances to resist the motion of the fluid or the layers of fluids within themselves. But in the same manner, you can assume this to be a kind of resistance that was offered during the flow of charges from one end to other. Means the electrical resistance is somehow analogous towards the viscosity. It is not perfectly analogous, but we can consider it to be a little kind of resistance that offered by the layers themselves and the walls in which the liquid is flowing. So this velocity depends on the radius of tube, let it be r, and this will becomes to be r raised to the power 4. Now next, in the same manner as in the resistance, larger is the length, so resistance was also larger. But here there is something different, that larger the length, the viscosity is small. Means viscosity is inversely proportional to length of the tube. This is length of the tube. And velocity is also inversely proportional to the viscosity. Here the velocity is, I guess I have said viscosity here. It is velocity when observed in terms of length. Then what happens? As the length increases, the velocity reduces. So these are vice versa thing, the opposite relation. Longer length, less velocity; shorter length, high velocity. So this eta is nothing but coefficient of viscosity. So combining all this, we come to the that it is P R L eta. And if this proportionality symbol is being removed, we get K P R4 by L eta. If solving about this equation, we get the value of K to be pi by 8. So the equation becomes pi by 8 P L eta. So how would you derive the equation? Where did you get the equation? Very simple. So derivation is just that we know that velocity depends on pressure, let it be power A, and pressure difference just is created. So this is depending on pressure gradient, since the pressure is being changed with respect to length only, and hence this pressure difference can be called off as the relation of pressure gradient. So by this, velocity is uh, basically depends on pressure gradient. Second, velocity depends on radius. Also, velocity depends on coefficient of viscosity. So these are the three factors on which the velocity of the flow of liquid is depending. So approaching towards dimensional formula derivation. So this, combining all this, we get or we can write this as this is now writing the dimensions of this. So V is equals to P by L. P by L is equals to P is pressure, so ml minus 1, T and length. So we get and R is radius, and coefficient of viscosity putting the values in the equation. 1 So this is the final equation we get here. We will solve this by principle of homogeneity. So what do we get? M is A plus C, L is minus 2A plus B minus C, and T is minus 2A minus C. So from here we get A plus C is equals to 0, minus 2A plus B minus C is equals to 3, and minus 2A minus C is equals to minus 1. Solving all this, so A is equals to minus C. Putting this value here, so we get minus 2 into minus C is equals to 1. So this is 2C minus C is equals to 1. So C is equals to 1. Sorry, it is minus 1 here. So C is equals to minus 1. So if C is minus 1, A will be minus of minus 1. So A will be 1. So putting value of A and C in this equation, minus 2, 1 plus B minus of minus 1. So this is minus 2 plus B plus 1. Solving this is minus 1 and this will go there, and the value of B, this is minus 1 plus, that will be 4. So we are getting A is equals to 1, B is equals to 4, and C is equals to minus 1. So V is equals to K P by L A R B eta C, putting the values here. So 1, 4, eta is minus 1, and hence P R4 L eta. So this is how you will derive the equation, and putting the value of K. So this can be determined experimentally is equals to pi by 8. So velocity is equals to pi by 8. Understood about this? So this basically depends on, we can rewrite as pi P R 8L eta is, let it be pressure by R. So where R could be considered as 8L eta pi R4. This is nothing but the liquid resistance. Okay, so the resistance which is offered by the liquid itself for the flow. So when the tubes of length L1 and L2 are joined in series, so L2 L1 having resistance R1 and L2 having resistance R2. So the overall resistance is equals to resistance offered by first plus resistance offered by second. That is 8L1 pi R1 plus 8L2 pi R2. So this will be the total resistance offered by the combination of two pipes or tubes of length L1 and L2 with radius R1 and R2, and the resistance offered for the flow of liquid will be R1 plus R2 complete net. And if the tubes are let us say joined in parallel, so this was in series, this was in parallel, so R net, same principle of that as it was in the case of electrical resistance. So 1 by R net is equals to 1 by R1 plus 1 by R2. So total resistance would be R1 R2, taking out the LCM, plus R2. Clear? So this was how we can derive and learn about the Poiseulli'S formula and the liquid resistance. This is of utmost importance. Okay, so we will observe the Stokes law in our next video. Thank you.